Hey guys, in this video I'm going to test what is the best maximum charging voltage for lithium iron phosphate batteries. Is it 365 volts as recommended per manufacturer, or maybe 355 or even 345 volts enough to charge battery and extend its life? I have here a lithium iron phosphate cell. It's 25 amp hours cell, and I'm going to perform 3 tests, as I said, and for each test I'm going to discharge battery to 2.5 volts. For all of these tests I'm gonna build this device using Arduino and this microchip, which is going to track how many amps going in or out from a battery and track voltage for the battery. Information is going to be stored every 15 seconds, so we can build graphs and see discharge and charge curve for our cell. Also, I'm gonna add this tiny screen to system just to quickly see what is the amps and voltages going into or out from a battery. To discharge, I'm going to use this discharger, which is going to track information, how many amp hours we draw from a battery. Okay, if you're interested to see all of these tests and check results, let's jump to the video. And here I'm starting first test. My power supply lab set to 365 volts, battery right now fully discharged at 2.62 volts, and the Arduino is tracking voltage and amps going in or out from a battery. So now I'm just going to connect charger to battery, and we see that we are charging with 5.3 amps, and the Arduino start tracking what is the amps going into the battery. And we are about 5 hours later. We see that our battery at 365 volts fully charged, and the power supply lab just outputting 17 milliamps. And now I'm going to start discharge test, and we'll come back in about 5 hours and see results. And we're also storing data, so we can see this on the graphs. So 5 hours later, we can see that our test is about to finish. And from this battery, we got 24,844 milliamps. So this is going to be our test data. This is what we're going to compare with other tests. Here is a graph for charging curve. If I display voltage for now, we can see that I started test at 2 p.m. and the voltage was 261. And at just after 2 minutes, 21 minutes, voltage jumped to 327, and it was like a big jump, and then it's just stay relatively flat. Then after 4 hours 30 minutes, voltage was 348 volts, and it was second jump, so we jumped to 365, and this jump took another 30 minutes. So this is standard lithium iron phosphate charging curve that you will see on internet. If we look at the current with voltage, so we see that we charging with 5 amps entire way till 6:40 p.m. when our voltage start raising. So as voltage raising to 365, we drop in amps, and at about 7:40 p.m. we just charging with 100 milliamps, so we can call the battery is full. So entire process took 5 hours and 40 minutes. For discharge curve, let's see how this looks like. So for voltage, also standard lithium iron phosphate or lithium batteries curve, we start discharging at 367, and it was 11:40 p.m. and just after like 7 minutes our voltage dropped to 326, huge drop, and then it's just stay like almost flat line. Not of course flat line, but almost flat. And then when voltage reaching about 310 volts, it's dropping quickly, and current is square, like 5 amps, because lithium can do 5 amps entire way. Okay, so here is a discharge curve. Let's jump to the 355 volts tests. Okay, now let's set our charger to 355 volts and charge our battery. Few hours later, you can see that cell at 355 volts and I'm pushing just 40 milliamps into the battery. So I'm going to disconnect chargers and start discharge test. Let's come back in 5 hours and see what capacity we got from this cell right now and what is the charging graph. And after 5 hours, here's the results for 355. So we got 24,764 milliamps from this cell. Okay, and here's a graph for 355 volts charge. So let's zoom this graph. And we started our test at 4:44 a.m. and we finished charging at about 10:40 a.m. So charging took 6 hours. And basically, it's the same graph that we saw before on a 365 volts charge. So if we look here at about when voltage reached 345 volts, it started decreasing our amps. So amps right here just like dropping quickly, and it dropped less to an amp when we were at 352 volts. Okay, discharge curve I'm not gonna even check because it's gonna be same as a 365 volt discharge. It's going to be same for every voltage. Now let's jump to 345 volts test. So here I'm about to start 345 volts charge test, and because 345 on the edge of this lithium iron phosphate curve, I'm setting two chargers to 2.5 volts to eliminate any power loss in the wires. So I want this test to be as much accurate as I can. Okay, so I came back in the morning, we still charging with 130 milliamps. So I'm gonna leave charging for a few more hours. I'm just going to disconnect the top charger because it's not charging anymore, so it shows 0 amps, and just leave bottom one, which is outputting 134 milliamps into the battery. Let's wait a little bit more time and come back later when charging is finished. Okay, and here we, few hours later, you can see that we are putting into the battery 47 milliamps. So at this point I'm going just to save charging information, and we will proceed with the discharge test. And 5 hours later we're getting our results for 345 volts. So we got 24,672 milliamps. Let's jump to the graphs and see what the charging curve was for 345 volts. Okay, and here is the charge curve for 345 volts. Let me zoom into this curve. And we can see that we started our test at about 4 p.m. and we finished this test at, what is the last time? At 2:40 a.m. So our charging when we did it, let's do 100 milliamps, so it was 2:30 a.m. So charging time took 10 hours to charge this battery. If we see voltage, in our case we don't have this spike that we have at the end for 365 or 345. So our voltage was like flat line, and because we stopped at 345, we don't have this spike at the end. And current, if we see for the current, we were charging at 5 amps, but then amps start like quickly dropping to 4 amps, 3 amps, because our battery was like closer to 345 volts. And we see that for entire time for this battery, we almost didn't charge with a full capacity of power supply. Okay, now let's combine all of this data in a table. Here's the combined results for all 3 tests. 365 volts, charging time took 5 hours 40 minutes, and we've got capacity of 24.84 amp hours. For 355 volts, charging time took 6 hours, which is increase of 6% if we compare to 365, and we got capacity as 24.76 amp hours, which is just 0.3% decrease from original capacity. For 345 volts, charging time was 10 hours, which is 76% increase of charging. And capacity, we've got 24.67 amp hours, which is decrease of original capacity of 0.6%. Now, when we have all this information, it's your decision what is the maximum charging voltage for lithium iron phosphate batteries. In my opinion, it should be anywhere between 345, maybe 350 and 355, and we're gonna still have 100 milliamps safety gap. If our battery not balanced, then one cell could reach 365 volts, which is still safe. Okay guys, I hope you like this video. If you do, please hit like button, consider subscribing to this channel, and as always, thank you for watching and see you later.